So this is our first lesson on Unit 10, which is going to be factoring. But to begin with, we looked at a few key things as a little bit of a reminder. So we looked first of all at prime numbers. So I asked the class what was the first prime number, I asked what is the definition of a prime number, and there was a few mistakes. So this is the factor. The key here is a number that only has two factors. So itself and 1. A lot of people think that 1 is a prime number because it divides by itself and also divides by 1. Unfortunately, itself and 1 are the same thing. So 1 only has one factor, which is why it's not prime. A lot of people remember if you divide a number by 2 that it's not prime. However, 2 works perfectly okay. 2 divides by 2, which is itself, and it also divides by 1. So the first few prime numbers are 2, 3, 5, 7 and 11. And the reason that 4 isn't a prime number is it divides by 1, 2 and 4. So there's more than 2 factors. And same for other numbers. 6, 1, 2, 3, 6. So more than 2 factors. If we're going to carry on to try and find the next one, 12 clearly doesn't work. 1, 2, 3 and a lot more. 13 does work because the only numbers that divide into 13 are 1 and 3. Now, one other key skill is when we're factoring, what we're actually doing is writing things that multiply together to give us what we're looking for. So if we're trying to factor a monomial just a single term here. So 12, we've got to think what times together to give us 12. We have to use these prime numbers here. So sometimes this is referred to as the prime factorization as well. X cubed, remember, just means x times x times x. As there's no power on here, we know that it's y to the 1, which is why there's just one here, one y here. And then z squared, z and z, so we have 2 z's. So fairly easy to factor a monomial. Now, we also did a quick review of GCF, which is the greatest common factor, which people had looked at in middle school before. And it's just another way of saying what is the biggest times table that the two numbers appear in. And sometimes it's easy, and you can just look at the numbers. So 1 is always a factor of both numbers. You just got to think, can you think of a bigger number? So clearly both of these numbers divide by 2. And then you just got to try some bigger numbers. So 3's divide into 6. But not into 20, so that's no good. Only another number divided into 6 would be 6, but 20 isn't in the 6 times table. So sometimes you can look at these by knowing your tables well. So 6 and 15, I know they're both in the 3 times table. I can see 15's in the 5 times table, but 6 certainly isn't. The fact these both end in 5 is a big clue that probably 5 is our answer to this question. And the fact that these end in 0 does tell you they divide by 5, but also they divide by 10. And you just got to make sure that there's no bigger factor. Certainly I would check 20s, but 20 doesn't divide into 50. Now, if the questions are more difficult, like 42 and 60, then that's not really quite so obvious. So what we can do is we can start doing our factor tree. So we have to think of 2 numbers at times to make 42. Now, we're going to use those prime numbers from the previous side. So let's try. Does 2 divide into 42? And it certainly does. And you can check it divides in 21 times. Now, if you get a prime number, you should circle it. That tells you to stop on that number there, because we don't want to carry on. If we did carry on, 2 numbers that times make 2 would be 2 and 1. But then I got my 2 again, and what times together to make 2? 2 and 1. And I would go on forever and ever. So once we get a prime number, we want to stop at that point. Now, 21, let's see if it divides by 2. No. So let's move on to the next one. Does it divide by 3? It absolutely does. And it divides in 7 times. And notice 3 and 7 are both prime numbers. So there's nothing left on my tree. And notice that if you times these 3 numbers together, you actually get the number that you start with, so you can check if you've done this correct. Now for 60, if I try 2, it goes in 30 times. I can try 2 again, and it actually goes in 15 times. 2's not going to 15, but 3's do, and it goes in 5 times. Once I got my prime numbers, don't forget to circle them, and then we should be able to write our answer down to show what the prime factorization of each number is. Now, just so you're aware, there are different ways of doing these questions as well that will still give you the right answer. So for 60, you might have swallowed, with it being a 0 on the end, 6 times 10. And for 6, that's 2 and 3, and for 10, that's 2 and 5. But look at the numbers that I finish up with. I still have 2 2's, a 3, and a 5. So I still end up with the same answer. Now, once we've actually got those 2 numbers, we can draw a Venn diagram. And what I'm looking for is, and I'm just going to get rid of this part here so we can see again what I actually did. is I'm looking for numbers that appear on both lists. So I can see that I got a 2 and I have a 2 here. So I write a 2 in the middle here. Now I also have a 3 and I have a 3 on this list here. So I wrote the 3 on that side. I had one number left on the 42, so I put that in this section of the 42. And on this section I had 2 numbers left, so I put the 2 and the 5 on this side. Now if you were to look at this circle for 42, all these numbers together times to make 42. And if I was to look on this side, all these numbers times together give me 60. Now the reason I've done this as a Venn diagram is, if you look at the intersection where these two numbers lie, if you multiply these two numbers together, 2 times 3 is 6, and that's actually how you find the GCF. You look for the numbers that appear in the intersection and you multiply them together. Now there is another useful thing that you can do with the Venn diagram that we don't actually need for Algebra 1, which is also to find the least common multiple. And to find the least common multiple, you just times all of these numbers together. So I can see this as 10, 30, 60, 420. So 42 you can see divides into 420 10 times, and 60 divides into 420 7 times. That's the smallest number that both of these two numbers divide into. More importantly for us, we're just looking at the GCF though. Now the homework for today's lesson was just to repeat that exercise I just did with the factor trees, but with these numbers. That's just to find the GCF, so that means that you're going to have to draw the Venn diagram, look for numbers that appear in both, and then go ahead and label them. Now I'm going to show you one more example with a few extra numbers, just so you can see how it works. Let's suppose this is my first list, and this is my second list. So when I do, I'm going to call it A and B. So when I do my Venn diagram, the numbers that I'm looking for numbers that appear in both lists. So I can see that there's a 2 appears in both. You might just want to cross them out as you go along so you don't forget. And notice there's another 2 this time. I have a 3 in both. Now I can't put this 3 in because there's no 3 left on the top here to go. I can't put the 5 in because there's no 5 on the bottom. And I don't have any 11s on both, and I don't have any 7s on both. So my GCF for this one, if these were the numbers I had, it would be 2 times 2 times 3, which is 12. So just take a little bit of care as you're filling in those Venn diagrams, and then you should be able to find a GCF, which is going to be an important skill for the following lesson.